Guys, welcome back sa ating data analysis. Now we just finished the midterm part 1 and part 2. Now we will be discussing the lessons for the finals. So we have for the first part, we have the measures of central tendency and measures of dispersion. Then for the second part, we have the box plots and measures of concentration. For this lesson, we'll be discussing these two, measures of central tendency and measures of dispersion as part 1. So let's go now with measures of central tendency. So a natural human tendency is to make comparisons with the average. So for example, the student scoring 40% in examination will be happy with the result if the average scores of the class is 25%. If the average class score is 90%, then the student may not feel happy even if he got 90% right. Some other examples of these average values in common are mean body height, mean temperature in July in some town, the most often selected study subject, the most popular TV show in 2015, and the average income. So, mostly every day ginagamit natin ang average data or information para ma-compare natin ang performance ng isang bagay with the performance of others. Okay? So we call it statistical functions which describe the average or center of data location parameters or measures of central tendency. So yan ang dalawang possible na tawag sa central tendency, location parameters kasi by determining the central tendency of the data, we can determine the location of the average. We have first method is the arithmetic mean. Ito, very common na ginagamit, especially sa computation ng mga grades. Actually, ito yung sinasabi nating average. So, I will not discuss yung equation dito, yung symbol, yung summation. Alam niyo na yan. Na-discuss na natin yan from our previous topics. Okay? So, meron lang siyang variation. We have 1 over n for the arithmetic because we have to divide it by in half yung data. So again, ang ating example, we have the absolute frequency, relative frequency. Ito yung ating mga class or groupings. In case na yung ating i-analyze ay group data. We have one variation ng arithmetic mean, which is the weighted arithmetic mean, which is used for group data. Okay? So pag nakita kayo ng FJMJ, that is a weighted arithmetic mean for group data. Okay, we have an example here. Okay, temperature in Bangkok during December. So we have 22 degrees, 24, etc. Hanggang the highest is 31 degrees. So to get the average down, we add the information or the data and divide it by the number of value of the n, the number of observations. Okay. For this example, we after dividing it, we get the 26.48 degrees centigrade. Okay? So, ganun lang kasimple yung arithmetic mean. So, let us assume meron tayong group data. Yan. So, less than 20. Ito naman, 20 hanggang 25 na temperature, 25, 30, 30, and then hanggang 35. Okay? So, for calculating the weighted mean, arithmetic mean, we get the following, So, saan to galing? 12. So, dito to, which is the beginning. And then, yung ending natin is 18, And then, saan galing to? 22.5. So, dito to sa gitna ng 20 to 25, Ito, the same, gitna. This one also the same, Saan galing ang 0? 0 kasi yung 20 dito, 0. Ito rin 0. So we have to add them, So after adding them, multiplying this, and then adding, summing up, we get 25.7 as the weighted arithmetic mean for the relative frequency of group data. So, very simple lang din. We go now with the properties of arithmetic mean. First is the sum of the deviation of each variable around the arithmetic mean is 0. So, yung deviations daw niya, wala siyang deviation or Next, the data, if the data is linearly transformed, meaning kung magkaiba sila ng unit, transform natin. For example, centigrade, transform natin sa Fahrenheit, no? That is linear transformation. So if that is the case daw, there will be no difference between the two linearly transformed data. So yun yung two properties ng arithmetic mean. After ng arithmetic mean, we have the median and quantiles. Now, kung sa average or sa arithmetic mean, dinidivide natin into two, sa median, ganun din, but in a different way, no? For example, the definition, no? The median is the value which divides observations into two equal parts, such that at least 50% of the values are greater than or equal to the median, and at least 50% of the values are less than or equal to the median. Ano ibig sabihin nun? To make it short, no? Meron tayong dalawang method. If n, which is the number of observation, is odd, then the preferred or the computation, no, or formula to be used is x times n plus 1 divided by 2. If n is even, it should be equal to the arithmetic mean. No? Our example for the temperature in Bangkok in December, if we get or if we use the median to get the central tendency for this example data, we have n as 31. So we have an odd observations. So we use this formula, okay, the first one. So we get 31 plus 1 divided by 2 will give us x16. So it will give us 26. Okay? So ibig sabihin ng 16, yung ika-number 16, which is this one, number 16, ay 26 siya. Okay? So remember, ito yung temperature, ito yung index number, no? Yan, yung series ng number kung hanggang ilan, no? So sa ika-16 na number ay si 26. So if the result is x16, then the value of this is 26. So ito yung ating median, okay? But if we have only 30, for example, and if one value was missing, let us say the last observation. So, ibig sabihin walang 31, no? Wala ito, hanggang 30 lang. So, we only have 30 observations. So, what do we use? We use the second formula, okay? So, the result is 1 half 26 plus 26, it will give us 26, okay? So in this example, we have the same median, no, for the two conditions, no, odd and even. So complicated kasi itong example na to, no, but if we will use a simple example, no, for example, we have 5, 10, 10, 15, 16. Yung even muna tayo, no, even. Okay, so we have 6, no? 6 data. So even siya. So anong gagamitin natin? Ito. Okay? So ano yung n natin? 6. Kasi meron tayong 6 na data over 2 plus ito 6 over 2 plus 1. 6 over 2 plus 1. Okay? So we have 3. 3 plus 1, we have 7. So sabi dito, divide sa 2. So what we will have is 3.5. Okay? So 1, 2, 3 in half. So yung nasa gitna ang ating median. Okay? So to find the median, we have to add these two, no? 10 plus 15 divided by 2 will give us 12.5. So median natin is 12.5. Okay? So kung add naman, we have a simple computation, no? So, for example, wala yung 18. So, ito ay 10. Wala si 18. Yan. So, we have 5, which is odd number yung ating data, no? So, we use the formula, this one, n plus 1 divided by 2. So, we have 5 plus 1 is 6, okay, divided by 2. So we have 3. So 1, 2, 3, then our median is 10. Okay? So ganun yung simple example natin, no? Para sa median. So we go now with, ito yung para sa group naman, group data. If we deal with group data, we can calculate the median under the assumption that the values within each class are equally distributed. So ito yon, no? Ayan. Ito yung group data natin. So anong gagawin? So hanapin mo lang yung gitna niya, no? So ano tong 0.5 na to? Saan galing to? Saan galing din yung 0.5? Yun yung half, no? Na galing yan sa formula. Yun. Galing sa formula. Okay? So, yun yung at kukunin natin yung lowest and then yung highest dun sa group, which is 30. Ito yon. Yan yung group na to. Pag nakita kayo ng F, that is group data. So, yung lowest, highest. Yan. So, galing sa 25, siya yung EM-1. Ano yung EM-1? Yun yung lowest dito. Okay? Dito sa ating group. Ang first step kasi is to identify kung nasan yung ating mean average, no? Ay yung ating median, no? So nandito yon sa 25 to 30. So ano yung 25? That is the lowest limit, 25 within the group. And then ano yung 0.5? Ito yung actually dito 0.5, ito ay times 5, no? According dun sa ating formula. So, ang gali yung 5, ito yung DM. Okay? Kung ito yung EM-1, ito yung DM times 5. Ano yung 5? Yung width nung yung distance ng bawat grupo. For example, itong distance is 25 to 30 is 5, no? 25 plus 5 will give us 30. So, ang distance nila ay 5 units. So, times 5. So, 25 yung ating lowest limit. Okay? So, lowest limit plus the summation. Ito yon 0.5 minus 12 over 31 over 18 to 31, which is, ito, hindi natin ito ginamit, no? Ito yung ating representation lang within the third class, no? Dinetermine lang natin dito kung nasan yung median. And we located that dito sa third M3, no? Yung class or group data na third group data. Okay? So we use 18 over 31, no? Hindi 30 over 31. And then after computing this, we will get 25.97 under sa group, no? Group data. So yan ang median. Sa single or hindi siya group, okay? Ang ating median ay 26. Yan, 26. Okay? So we have different representation ng median at saka mean, no? Sa symmetric data daw, halos pareho lang sila ng location. Ayan, nasa gitna. Sa skewed data, ibig sabihin medyo may konting deviation, no? Yan, skewed siya. Ito kasi ay yung sinasabi ko, ay na-discuss natin before, no? Na yung parang bell shape, okay? Normal distribution to. Yan. Ibig sabihin symmetric yung distribution ng data, no? Sa skewed, medyo nakaano siya sa kanan, yan. So sa skewed daw, medyo magkahiwalay, no? Ibig sabihin magkaiba sila ng value. Sa bimodal naman, ibig sabihin dalawa ang kanyang peak, no? Dalawang taas baba. Magkahiwalay din siya, magkaiba ng value, halos magkalayo na. Okay? Dito kasi medyo magkalapit pa sila. At kapag with outliers, pag sinabing outliers, merong mga abnormal information or data ka na nag-gather, no? Or nakuha dun sa iyong experiment or observation. Okay? Kung sa loob ng klase, o sa may mga nag-exam, may nangopya. Parang gano'n, no? Mga outliers. Yan. So, halos magkahiwalay na sila, no? Yung magkaiba sila ng value at location. So, yan yung comparison, no, ng mean and median. Arithmetic mean and median for different data. Okay? Ano naman yung quantile? So, quantiles are a generalization of the idea of the median, no? So, the median is a value which splits the data into two equal parts. Okay? Sa median, dinidivide lang natin ng two equal parts, no? Dalawa, pero equal, no? But sa quantiles, pag sinabi mong quantiles, dinidivide natin ang mga data in different proportions, no? For example, 25% sa left, at yung other side or ang other part ng data ay 75%. So, dinivide natin sila into 25 and 75, no? Hindi equal parts. Okay? So, meron tayong iba't ibang type nun. Yan. Deciles kapag the quantiles are called deciles if we divide the symbol which is the alpha ng tig 10. For example, 0.1, 0.2. Okay? Kung ang value ni alpha daw, ni alpha ay 0.1, 0.2, hanggang 0.9, then the quantiles are called deciles. If the value of the alpha is multiplied by 100 and give us 95, for example, then the quantiles are called percentiles. The data is divided into 100 equal parts, ang ibig sabihin ng percentiles. Sa deciles naman, they are divided into 10 equal parts, no? If the alpha takes the values of zero point 0.2, zero point 0.4, zero point 0.6, so on and so forth, the quantiles are known as quintiles, and they divide the data into 5 equal parts. The alpha takes the values 0.25, 0.50, and 0.75. The quantiles are called quartiles, no? So, dinivide niya yan ng quarterly, no? For example, we have the evaluation of the temperature in Bangkok again in December. So, ito yung ating information. The temperature, the index number, yung sequence number nila. Number of observation, 31. Okay? Lowest natin is 21. Highest is 31 degrees. So, to determine the quartiles. So, pag sinabing quartiles, ano? So, quarterly, no? So, 50 to 25. So, 25, 50, 75, and then 100, no? So, we calculate N alpha as 31 times 0.25 and it will give us 7.75. So, ano yon? Ito yon, no? Gawin na natin 8 yan. 25 siya. Si 25 yung ika-25th na quartiles. Sa ika-75, that will give us 24. Ito yon. So, kung ano si 24, nasan si 24? Ika-24 daw, ito yon, no? Ibig sabihin, lahat mula dito kay 8, pataas hanggang dito kay 24, siya yung mga estudyante, kung ito ay grade, no? Siya yung mga estudyanteng, sila yung mga estudyanteng kasama sa 75% ng, for example, nag-exam sila, yan, 75% ito, belongs to the 75%. Kung ang score mo naman ay nandito, up to here, sa hanggang 8, ika-25, you belong to the 25%, no? Ng nag-take ng exam. Yun ibig sabihin nun, no, ng quartiles. Yan. So with regards naman, no, sa representation sa graph between the median, no? So we use the delivery time sa example natin before sa midterm, no, yung pizza delivery time. Ito yung kay Luigi, ito yung kay Mario. Okay? So kung ano daw to, kung distribution ng ating data ay nakaayon, no? Okay? Along with the lines, then ibig sabihin walang pagkakaiba sa performance ni na Mario at ni Luigi. But if daw na mas lumampas dito sa baba ng line yung ating information, then ibig sabihin yung performance ni Luigi is greater than the performance of Mario. We go now with QQ plots. If we plot the quantiles of two variables against each other, we obtain a quantile plot, or QQ plot. So yun, yung nasa taas, no? To determine, no? To compare the performance of two data. Yan, we use the quantile Q plot. Okay? So ito yung ating different variation, no? Yung possible situation na pwede mangyari. So along the lines, pareho ng performance. Under the lines, the first data is better than the second. Kung upper, yung kanyang position, the second data is better performing than the first data. And if na-break yung kanilang setting or ang kanilang location, then that means there is no higher or lower better performing between the two sets of data. We go now with the mode. So first we'd explain the arithmetic mean and then the median. The third type is the mode, no? So consider a situation in which an ice cream shop owner wants to know which flavor of ice cream is the most popular among his customers. Yan, pwede mong gamitin yung mode, no? Sa pag-determine ng kung anong product yung mas mabenta. Similarly, a footwear shop owner may like to find out what design and size of shoes are in the highest demand. To answer this type of question, one can use the size of shoes, no? And what design are in the highest demand, no? Using the mode. We call the pizza data set. The pizza delivery service has three branches. Okay, ito yon. Meron daw tayong performance about branch. Ito naman yung performance in general. Okay, in minutes. We have a bar chart for branch. We have the histogram for group delivery time. Yan, in minutes siya, naka-group. Using the mode, we can easily determine yan, no? Kung alin dyan yung most better or the better performing data. Okay? So dito, we have the West, no? Dito naman, we have pinakamabilis is under ng group ng 30 minutes. Yan. Titingnan mo lang kung anong data yung mabilis or laging na lumalabas, no? For example, uh, we have the following data, no? Following grades, for example, uh, 70, 75, 75, 60, ay, teka bumaba. 80, 80, 80, and then nagkaroon ka ng 91, 91, and then 95, no? So 2, 4, we have 2, 4, 6, 8, 9 grades, no? 9 data. So out of this, ang laging lumalabas, mas maraming lumabas si 80. So ang mode mo ay 80. Okay, this is your mode. Yan. So you don't need to compute for the average or the median, no? You just need to find out which information has more observations or occurrence. Okay? That is the definition of mode. We go now with geometric mean. Bigyan na lang natin definition. Geometric mean plays an important role in fields where we are interested in products of observations, such as when we look at percentage changes in quantities. Yan. Ito yun. Take note, percentage changes in quantities. So let's go now with the example, no? Para mabilis nating ma-absorb. Ito, example natin, no? We have an inventory, we have the growth factor, we have the growth rate. So, meron tayong time, okay? 0, 1, 2, okay? So, ito yung changes niya. Merong, ito yung initial, and then change 1, change 2. So, ibig sabihin, dumarami siya. So, we can calculate, no? By using the growth factors. So, paano kunin yung first growth factors? We divide the initial value we divide the second value by the initial value. The second growth factor is computed by dividing the initial value, the new or current value by the past value. Okay? That's how you compute for the growth factor. Then, after computing the growth factor, we can then compute for the average growth factor, no? By taking the total, yan, BT over BT minus 1, you can determine no, the average growth factor. So, example natin, suppose someone wants to deposit money, say 1,000 in a bank. The bank advisor proposes a 5-year savings plan with the following plan for interest rates: 1% in the first year, 1.5% in the second year, 2.5% in the third year, and 3% in the last 2 years. Now he would like to calculate the average growth factor and average growth rate for the invested money. The concept of the geometric mean can be used as follows. No? So we have the year. Okay? We have the year and we have the investment. So, nag-invest siya ng 1,000. Since sa first year, meron tayong 1%. So, nag-accumulate siya, 1,010 na. No? So, ang growth factor niya, kinompute natin is 1,010 divided by 1,000 will give us 1.01%. And then, the second is 1.5%. So, nagkaroon siya ng 1,025.15. So, how do we compute for the yearly growth factor? We have 1,025.15 divided by 1,010 will give us 1,015. So on and so forth. And then compute for the total. And then, after computing the total and dividing it by the number of growth factors, we will get the average growth factor of 1.022%. Okay? The same way with the growth rate, no? So the growth rate is computed by, tingnan natin yung original formula. Yan. Growth rate computed by deducting 1 from the first change and then multiplying the by it by 100. The savings after 5 years, we can multiply the derived average growth factor with the initial investment. So for 5 years, we have the 1,114.77 as the total earnings. Next, we go now with harmonic mean. Harmonic mean is typically used whenever different xi contribute to the mean with a different weight. No? So parang weighted ano to, no? Weighted average. So bawat weight or bawat observation may kanya-kanya siyang factor. No? So for example, when calculating the average speed, each weight relates to the relative distance traveled. Siyempre, magbabago yung distance mo. No? Every time na kukumputin mo yung specific speed niya for a certain location, no? Or for a certain distance travel. Tayo ditong example. Suppose an investor bought shares worth 1,000 for 2 consecutive months. The price per share was 50 in the first month and 200 in the second month. So, yun yung kanyang price ng per share, no? What is the average purchase price? No? So, to compute, for the first month, we have 1,000. 1,000 kasi yung kanyang total shares na nabili. Divided by 50, which is the amount per share. So, we have 20 shares. The same way with the second month, we have 1,000 divided by 200, we'll get 5, no? So if we manually compute this, we have overall we have 25 shares, no? So second month we have 1,000. I mean, first month we have 1,000 investment. Second month we have again 1,000 investment. So we have total of 2,000. If we divide 25, if we divide it by 25, we have 80 as the average purchase price, no? But that is computing manually, no? But if we use the formula, this formula for the harmonic mean, we will have the same, we will arrive at the same amount, no? So 1 from the formula, saan galing yung 0.5? 0.5 is the weight for each investment, no? For each month. So first month is 1,000 over 2,000, then the sharing of that, the ratio is that the weight for that is 0.5. The second month is the same since we have the same investment, no? 1,000 din. So 1,000 over 2,000 will give us the same weight, no? So 0.5 over 50 plus 0.5 over 200, which is the amount per share for the second month. After computing this, we will arrive at the same average, no? Harmonic mean. We use harmonic mean if we want to compute the number of observations with different weights, no? We compute geometric mean, we want to analyze, no, the growth, no, per changes, no, per time, okay? So that is the lesson, no, for the central tendency. We have arithmetic mean, we have the mode, we have the median, and then under ng arithmetic mean, we have the weighted arithmetic mean, we have geometric mean, and this one, the last one, we have the harmonic mean. Now we go now with measures of dispersion. No? Measures of central tendency, as introduced earlier, gave us an idea about the location where most of the data is concentrated. However, two different data sets may have the same value for the measure of central tendency, say the same arithmetic means, but they may have different concentrations around the mean. No? So, ibig sabihin kasi ng measures of dispersion, if we have the graph, for example, may graph tayo, ganyan, no? So, nandito yung na-locate natin yung kanyang, let's say, for example, meron tayong normal distribution. So, sa normal distribution, we have the center, no? Nasa center yung ating mean. Okay? So, pag sinabi mong central tendency, yung location ang binibigay niya. Ito, narito siya sa gitna. Pag minsan naman, kung ang ating distribution ng ay medyo skewed, no? Sa left side, yun yung center niya, narito, nandun siya sa left, no? So yung location mo ng peak, no, iba, okay? So, yun yung binibigay, no, nung central tendency, whether it's centered or not centered, skewed, symmetrical, or what, no? Under ng measures of dispersion, yung groupings, ang binibigay sa atin ay yung groupings ng data, no? For example, nandito yung tendency, but yung groupings ba ng data mo nasaan? Malapit ba siya sa gitna or magkakalayo? Yan, parang gano'n, dispersion. Or nasa gitna siya, ganyan. Yan. Or malayo, sobrang layo, gano'n. Yun yung ibig sabihin ng measures of dispersion, no? Kung paano nakalocate yung iyong mga data sa graph in relation to the center, no, ng iyong data. So, under ng measures of dispersion, the location measures may not be adequate enough, no, to describe the distribution of the data, the concentration or dispersion of observations around any particular value is another property which characterizes the data and its distribution. We now introduce, no, these statistical methods which describe the variability or dispersion of data. Suppose, for example, we have three students, Christine, Andres, and Sandro. Okay, ito yung kanilang attendance. So, yan, late, okay, ahead of time, late. So, sa Christine, laging on time. Ito, pag minsan late, pag minsan ahead. Ito naman, madalas ay late, pag minsan ahead, late, pag minsan ahead. Yan, si Sandro. So, if we compare daw, pwedeng maging pare-pareho sila ng average, but yung distribution ng kanilang data, no, with regards sa kanilang pagpasok, no, sa kanilang tardiness, will be different. Okay? Under ng measures of dispersion. So, this knowledge can be summarized by the measure of dispersion. The above examples highlight that the distribution of variable needs to be characterized by a measure of dispersion in addition to a measure of location or what we call the central tendency. So first method, we have the range and interquartile range. So by definition, the interquartile range is defined as the difference between the 75th and the 25th quartile as follows, no? So 0.75 minus 0.25. So it covers the center of distribution and contains 50% of the observations. So yan ang definition ng ating quartile or interquartile range, no? We'll go now with the example. So using the 25th quartile, it will give us 25. And for the 75th, ito yung kanina example natin, no? 29, yan, 29, ito yon. 25th, ito, 7. The interquartile range is therefore 29 minus 25 equals 4, which means that 50% of the data is centered between 25 and 29. The range is 31 minus 21, 10 degrees centigrade, meaning that the temperature is varying at most by 10 degrees centigrade. We go now with absolute deviation, variance, and standard deviation. Another measure of dispersion is the variance. The variance is one of the most important measures in statistics. Is needed and is needed throughout this book. We use the idea of absolute deviation to give some more background and motivation for understanding the variance as measure of dispersion, followed by some examples. So again, the same standard summation formula natin. No? So hindi ko na-explain yan. So, again, definition ng ating aalamin, no? So, the absolute median deviation. Okay? Another solution to avoid the positive sign. Okay? Ito yan, definition. It can be shown that the absolute deviation attains its minimum when A corresponds to the median of the data. Ayan, ito yung median, no? 0.5. Nakita nyo to, x 0.5, this is the median. Okay? So, absolute median deviation. Ito yung ating formula. Formula for the another method to avoid the positive and negative signs of deviation, we use the square. No? So, this provides another measure of dispersion as which is known as the mean squared error. So, MSE. Yan, ito yung tawag doon. No? The MSE is another important measure in statistics. It can be shown as S squared A attains its minimum value when A is equal to the variance. The positive square root of the variance is called the standard deviation. Okay? So, kung positive daw yung variance, we call that standard deviation. The standard deviation has the same unit of measurement as the data, whereas the unit of the variance is the square of the units of the observation. Gamit ng standard deviation, the standard deviation measures how much the observations vary or how they are dispersed around the arithmetic mean. So, a low value of standard deviation indicates that the values are highly concentrated around the mean. Sabihin, magkakalapit sila sa gitna. A high value of the standard deviation indicates lower concentration. So, medyo na malayo sila sa mean, malayo sa gitna. And some of the observed values may even far away from the mean. Yan, malayo sila. No? Especially daw kapag merong outliers. No? So, sobrang layo na kapag meron tayong tinatawag na abnormality or outliers na data. Ito naman yung pagkuha ng variance for group data. So again, pag nakita kayo ng F, saan yung ating F? That is indicating, ito J pala, yan. That is indicating the group data, no? So we have to find the middle value of the J interval, no? Ng group data. So parang yung kanina, 25 to 30, hanapin mo lang yung gitna, no? Between that upper or lower and upper limit. The two expressions represent the variance between the different classes. Yan. They describe the variability of the class-specific means. So, ito yon yung kanilang, para makuha mo yung gitna, no? So, dapat daw, kunin mo yung variance between the different group data or the what we call classes in order to find the variance for each or within group data. Ayan, between or within. Okay? So, between, ito, meron tayong minus. Within, ito yung ating ginagamit na formula. So, example, recall the weather data. The group data is specified as follows. Okay, the same example. But we have the additional information here. So, we know the variance is 26. I mean the mean. The number of observation is 31. The first step is to calculate the mean and variances in each class using the formula above. We then obtain xj and sj as listed above. Ito yon. The within and within variances are as follows. Yan. So, saan to galing? Ito yung 1 over 31 galing dito sa formula. 1 over 31. 12 galing sa second group. 12 observation times the SJ plus N, 18 again, then SJ again, then 1 times the SJ again. Okay, so this one and this one, ginamit natin sa formula na to. Then we get the 1.925 no, as the variance. The total variance therefore is 6.64. Adding this one and this one, no? Estimating the variance using all 31 observations will yield the same results. Linear transformations, again, ito yung pagko-compute, no? From one unit to another unit of measurements. Okay? Now, in relation to that, we have what we call the standardization. The variable is called standardized if its mean is 0 and its variance is 1. Standardization can be achieved by using the following transformation. So we have again the constant value of a plus bx, coefficient of variation. Consider situation where two different variables have arithmetic means xi, x1 and x2 with standard deviation s1 and s2 respectively. Suppose we want to compare the variability of hotel prices in Munich measured in euros and London measured in British pounds. So magkaiba sila ng unit of measurement. So how can we provide a fair comparison? Since the prices are measured in different units, therefore likely have arithmetic means which differ substantially, it does not make much sense to compare the standard deviations directly. The coefficient of variation V is a measure of dispersion which uses both the standard deviation and mean and thus allows a fair comparison. So we use the coefficient of variation to compute for the to make a fair comparison no, between two data which are computed in different units. No? So it is properly defined only when all the values of variable are measured on a ratio scale and are positive such that the mean is greater than 0. The coefficient of variation is a unit-free measure of dispersion. It is often used when the measurements of two variables are different, but can be put into relation by using a linear transformation yi equals bxi. It's possible to show that if all values xi variable x are transformed to y variable with values yi is equal to b times xi, if b is greater than 0, then b does not change. Yan, yun ang kanyang condition. No? Si x or si y ay or si b is greater than 0 dapat. Okay? So, this is the use or these are the uses of the coefficient variation. This is the end of our lesson for final lesson part 1. See you on the part 2.